The PurpleHat sensor has become a quite popular product over the last few months, as model railroaders all over the globe are successfully using it for speed profiling their locomotive fleets. Once in a while I receive questions and feedback, as well as suggestions for new features. In this video I give you an update on the ongoing developments, and I like to show you the new PurpleHat Mini. Hello everyone and welcome to the IoTT channel. I am Hans Tenner. Welcome to all first-time visitors and welcome back to everyone else. I am happy you made it here and thank you for your support of my channel. And if you're not yet a subscriber, please click the subscribe button below and hit the bell icon so that you're always in a premium seat when new videos come out. One of the best new features introduced in the last revision of the PurpleHat software is the ability to save and reload technical speed profiles. This allows the user to recalculate the speed table for a new throttle profile without having to rerun the technical speed analysis. Simply change the throttle profile to a new scale speed for a certain throttle position, then reload the technical speed profile, click the Recalculate button and program the new table values into the decoder. Besides that, it turns out that saved throttle and speed profiles are a valuable support tool. If you get stuck in the speed profiling process, it's easy to save the profiles and email them to me for review. I can then load them into a PurpleHat, analyze what's going on, and possibly give you some pointers for what to do next. Besides that, profile data is also a valuable input for improving the PurpleHat software. Looking over all that available data, it becomes clear that the most important contributors for successful speed profiling are Locomotive Preparation and Decoder Preparation. Make sure the powertrain of your locomotive is clean and does not have any hesitation. Maybe add a drop of oil if needed and suitable for the type of gear you are running. Check the maintenance instructions in your locomotive's owner manual for more information. Also, have a look at the power pickups and make sure they work reliably and the locomotive moves without interruptions even at the lowest speed settings. Don't forget to make sure the test track is cleaned as well. On the decoder side, the most important point is to make sure the locomotive is set to a linear speed curve that reaches the technical maximum speed. Most locomotives are designed to go way faster than the maximum scale speed of the prototype, so speed profiling in most cases is limiting the speed to a realistic scale speed. But for analyzing the technical speed profile, we need to look at the entire available speed range. The simplest way is to set the decoder to using Vstart, Vmid and Vmax values. For some decoders that means setting CVs 2, 6 and 5 all to 0. For others, the values for a linear speed curve to the maximum may be 0, 255 and 127. Check your decoder manual for more information, or simply try it out by setting the values and then use the PurpleHat to see what scale speed you get for various throttle positions. Another CV to look at is the kickstart value, if supported by your decoder. According to the NMRA standard, it should be CV65. Increase the value to give the motor a few extra kicks at very low speed settings to break loose the anchor and get the engine going. For good speed profiling, you want the locomotive to start moving at the first speed step. If supported by your decoder, also have a look at the speed stabilization settings. Different decoder brands use different names for this feature, but at the core it is an active measurement of the motor RPMs to make sure that the same speed settings result in about the same scale speed independent of the number of cars attached to the locomotive or the grade the train is traveling on. Use this feature if available and have it activated for the speed profiling process. Otherwise, you might find that your loco speed is much slower when it is pulling a real train or going up a steep grade. With these preparations completed, the automated profile analysis process should run without problems, and you should get a technical speed profile for forward and backward operation all the way to your targeted maximum scale speed. Unless there is a technical problem, and that gives me an opportunity to quickly talk about the problem with PurpleHat board revision 2. When I routed this board, I unfortunately overlooked that the 3.3 volt trace was put right in the middle between the two rows of soldering eyes, where you cut the board if you do a split vertical installation with an offset for the IoTT stick, so that both the sensor and the stick are centered on the car, typically for N-scale. If the trace is gone, the power supply to the sensor chip is interrupted. When I became aware of the problem, I immediately made a revision 3 of the board, which is now being used for the vertical mount version of the PurpleHat, and does no longer have the trace and therefore can be cut in half without problems. In case you did cut your revision 2 board and it is no longer working, not all is lost. You can simply solder a thin wire from the 3.3 volt pin of the stick side to the VCC soldering eye on the sensor side. If this is too complicated, please contact me for other options. In some cases, even the split vertical mount version might be too big for a small car, and one of my viewers, Giorgio from Italy, was running into that problem. So he contacted me basically asking for possibilities to cut away even a smaller fraction, and essentially using just the sensor part. Unfortunately, that is not just that easy, but after giving it some thoughts, I decided to put all components closer together and make a sensor board with a very small footprint that could even fit a C-scale car. And here we go, the PurpleHat Mini. The board dimensions are 6 by 10 mm and the board thickness is just 1 mm. As always, I have published the Gerber file for the PCB, so you can order it from any PCB manufacturer for very little money. Unfortunately, the board is too small to have it assembled, so you have to do it yourself. I built a small gauge to put the boards on so that they cannot move. Then I put on some soldering paste and placed the components. As you see, the microscope I showed you in video number 129 comes in very handy as the components are pretty small. I make sure that they are approximately in the right position and then place the entire board on the heating plate. The capillary effect of the melting solder will put the components into the final position, and if it does not happen automatically, a little push with a small screwdriver or tweezers will do the trick. You then can install the PurpleHat Mini board on top of the axle with the rotating magnets and connect the 4 contacts to the stick. VCC goes to the 3.3 volt pin, ground to ground, SDA is connected to G26 and SCL goes to the G0 of the stick. On the stick side I use a pin header so that it is easy to disconnect the sensor from the stick. I am in the process of adding the PurpleHat Mini to the Tindie store, and it will come with options. You can get just the ready-made and tested board, and you can add axle magnets, either 2 mm for N scale or 3 mm for HO scale. A set of wires and an 8-pin pin header for the connection to the IoTT stick will also be a selectable option. As with the original PurpleHat, the PurpleHat Mini can be installed flat or upright. Flat installation is in the travel direction of the car, and upright installation is with the soldering pads on the upside and the components close to the floor of the car. Once you have it installed, you can use it the same way like the original PurpleHat. You can connect to the web page of the stick, do all the settings and then use it to measure scale speed and travel distance, And of course you can also run the SpeedMagick profiling functions. Now, since I started that path to miniaturization, I am also looking into using a processor with a smaller footprint, and the M5 stamp looks like a real possibility. It is basically an IoTT stick without display, battery and some other peripheral components, but still featuring the powerful ESP32 microprocessor with Bluetooth and Wi-Fi. I am currently looking into what's needed to port the IoTT stick software, or at least parts of it, to this smaller platform. No promise right now, but chances are that this will result in a measuring car that fits the clearance profile of an N-scale track. We will see. And as always, as subscriber to the IoTT channel, you will be among the first to hear about it. And that brings me to the last topic of this PurpleHat update video: software changes. I am about to release version 1.6.5 of the IoTT stick software, and it has a few changes to the SpeedMagick tab. Let's have a look at it. The first change is additional options for the speed table calculation. Up to now, the speed table values were calculated from the average values of the forward and backward technical speed profile. In the new version, you now can base the table calculation on either the higher or the lower curve of the speed profile exclusively. This might be beneficial in case of big deviations between the two profile curves, or if one of the curves shows strong nonlinear behavior that might affect the average value calculation. Furthermore, you now also can define a trim reserve percentage that gives some more flexibility for using the trim values if your decoder is using the 0 to 100% trim range. In this case, the trim value of the slower direction would always be set to 255, and only the faster direction could be slowed down. With the trim reserve percentage, you can now make the table curves a little faster than what the throttle profile is asking for, and therefore you can use a trim value to reduce the speed of the slower curve to meet the target speeds. Of course, this option has no effect if your decoder has a 0 to 200% trim value range, because in this case the middle is at a value of 128, and you can make both curves faster or slower as you wish. The third change is in the throttle profile section. Here I added a programming button for changing the trim values. It works whenever the programming mode is set to main track. Activate the Show Current Speed checkbox to display the color dot that shows the current speed step and scale speed. If the programming mode is set to main track, you will get 2 additional input fields for forward and reverse trim, along with a programming button to write the values into the decoder. So you can make adjustments to make the loco go faster or slower at the given speed step, then program the values into the decoder, and you can immediately see the effect of the changes to the speed of your locomotive. And that's it for this video. I hope this was useful or at least interesting for you, and you are as excited as I am about the new possibilities that come with making everything a tad smaller. As always, if you have additional ideas or feature requests, please put them in the comments section of this video. Also, please do not forget to click the like button below. It only takes a second, but it helps to promote this video to other model railroaders, and it keeps me happy and motivated, as it shows your continued support for the IoTT channel in general. Thanks for watching, and see you in the next video.